Have you ever wondered how radar works? This marvel of technology that has become so integral to our modern lives, from aviation to weather forecasting and even in self-driving cars, has a fascinating history and an even more intriguing functionality. It all began with a simple observation by German physicist Heinrich Hertz in 1886. He noticed that radio waves could be reflected off solid objects. This was the first stepping stone towards the invention of radar. Then, in 1895, Alexander Popov, a physics instructor at the Imperial Russian Navy School, developed a device using a coherer tube to detect distant lightning strikes. The following year, he added a spark gap transmitter, laying the groundwork for what would eventually become radar technology. Fast forward to 1904, when the German inventor Christian Holzmeier was the first to use radio waves to detect the presence of distant metallic objects. He demonstrated the feasibility of detecting a ship in dense fog, though he couldn't yet determine its distance from the transmitter. He obtained a patent for his detection device and later for a related amendment for estimating the distance to the ship. He also developed a full radar system which he called a telemobiloscope, operating on a 50-centimeter wavelength with the pulsed radar signal created via a spark gap. The term radar, an acronym for radio detection and ranging, was coined later in 1940 by the United States Navy. This marked the official birth of radar as we know it today. During World War II, radar was developed secretly for military use by several countries. A key development was the cavity magnetron in the United Kingdom, which allowed the creation of relatively small systems with sub-meter resolution. Today, the uses of radar are highly diverse and continually expanding with advancements in technology. Air and terrestrial traffic control, radar astronomy, air defense systems, anti-missile systems, marine radars, aircraft anti-collision systems, ocean surveillance systems, outer space surveillance and rendezvous systems, meteorological precipitation monitoring, radar remote sensing, altimetry and flight control systems, guided missile target locating systems, self-driving cars, and ground-penetrating radar for geological observations are just a few examples of radar's modern applications. Modern high-tech radar systems use digital signal processing and machine learning and are capable of extracting useful information from very high noise levels. Other systems similar to radar, like LiDAR, make use of other parts of the electromagnetic spectrum, predominantly infrared light from lasers. In summary, radar, which began as a simple system for detecting metallic objects, has evolved into an essential tool in multiple industries. Its journey from a spark gap transmitter to the sophisticated systems we see today is a testament to human ingenuity and the endless possibilities of technology. Radar, in all its forms, continues to make our world safer, more efficient, and more connected.